Listen. Alright, here we go. Did I just press record? I did. Isn't my mouse cute? Look at that. Alright. I'm normal, I swear. Okay, I'm a normal human that does normal things. Right? Okay. Alright, let's look at his bell work.
Yeah, I did.
Okay, let's look.
Yeah, I did. You didn't do any of it.
I wrote a star and my name.
Caroline.
Alright.
Do you get offended when people say Caroline?
I mean, I don't get offended. I'm just like, hey, call me. Let's take them, please.
What's your real last name now?
My name will change to Crevo.
Are you gonna let people call you Crevo whenever you're next year?
Yeah.
Miss Crevo. That sounds like an old lady.
Okay, so let's look at first couple ones. Alright. Measure of QR is 110 and RS is 94. And then QRT is 27. That was the worst 7 ever.
That looks like a 9.
Your mom looks like a 9. That's actually not a diss. That means she's cute. Alright. So, let's look at these. So, that 27 is an inscribed angle, right? Alright, so this is, if we look, this is the arc that the 27 angle goes to. What do we know about inscribed angles and the arc? Chase, can you move back to your seat, please? The inscribed angle is what of the arc? Half, right. So this is half of QT. So then what's QT? 54, right. Alright, so QT, measure of QT. It's so cute. It's a cutie. Because this is an inscribed angle, and inscribed angles are half of the arc. So to go backwards, I have to multiply by 2. Alright, let's look. How can I find this arc?
You add 54, 110, 94 by 360.
Perfect. So I can do 360 minus these 3 arcs. Alright, what do we get? 102. Okay. Now, if I look here, 110, if I look at this arc, the endpoints are the endpoints of angle S. Okay? So this is an inscribed angle, and the inscribed angle is half of the arc. So if it's 110, and the angle is half of that, what's my angle? 55. So, do we even need that one? Nope, but it's good to find. Alright. Oh, we do. Here it is. Here it is. Sorry. I thought that said QRS. Okay, 55 degrees. Okay, let's see. So now it wants QTR. So that's the arc. So what do we know about inscribed angles that share the same arc? They're congruent. So then what's angle QTR? 55. Perfect. Yeah, and 55 is half of 110. Correct. That's another way to think about it. So RQS. I'm running out of colors over here. Alright, RQS. So that's this angle. So if I look, the endpoints are here, R and S, which opens up to the 94-degree arc. Perfect, half of 94. So what's that? 47. Close. All right. TRS. So TRS. TRS. Perfect. Yeah, half of 102 because TRS goes to this arc 102. So 51 degrees. So this module, it would be helpful if you had different color pens and pencils out just because it helps you keep some of this straight. You can kind of color it. And then once you're done, it should look like a hot rainbow mess, which is what it does look like. All right. So let's look here. So this is, what kind of angle is JKL? What kind of angle is it? Yes, but remember, the vertex is on the circle, so what do we call that? Perfect, an inscribed angle. So we know that the inscribed angle is the arc divided by 2. So that's how we're going to set it up. Do I know the inscribed angle? Yes, it's 83. And the arc is 9x plus 40 divided by 2. How do I get rid of that 2? Multiply by 2 on both sides. So 2 times 83 is 166. I did not leave myself a lot of room, did I? So 166 equals 9x plus 40. Subtract 40 from both sides. I get 126. Divide by 9. I get x is 14. So always write the formula. Okay, always write the formula because the vertex is on the circle. If the vertex is not on the circle, then it is not an inscribed angle. All right, let's look at number 3. What kind of angle is number 3? Nope, the vertex is still on the circle, so it's inscribed as well. I want you to write that above it because a lot of y'all are not speaking. This is also an inscribed angle. All right, so what's the formula for an inscribed angle? Awesome, so the angle is the arc divided by 2. All right, so what's my angle? Perfect, 5x plus 11. And then what's the arc? 16x minus 26. Perfect. Perfect. All right. So multiply both sides by 2 to get rid of that. So if 10x plus 22 equals 16x minus 26. Okay, take the 10x over here. I got 6x, add 26 to the other side, and I get 48. Divide by 6, x equals 8. All right, am I finished? Why not? Right, look what it asks for. It asks for the measure of the angle. So what do I need to do with the 8? Plug it in. Right. Plug it in, plug it in.
Wait,
Alright.
look at this.
Wouldn't it be 49?
It asks for the angle.
No,
Sorry, I'm talking to Gabe. What'd you ask?
wouldn't it be 49, not 48? That's 27 plus 22.
It's 20. It's 26.
51.
Yeah. All right, so I've got 5 times x, but we know x is 8 plus 11, so that's 40 plus 11, 51. So how could I quickly find the arc?
Just do half of it.
The other way around. So the angle is half of the arc, right? Multiply it by 2. Or you could also plug in 8 here. Those are the 2 different ways. Okay? All right. Let's just set these 2 up for time's sake. All right. So if you look, both of these angles what do they share? Right, they share this intercepted arc. Okay, they share this arc here. So what do we know about inscribed angles that share an arc? They're congruent. Okay, so inscribed angles that share an arc are congruent. Okay, so that's what we learned on Monday or Tuesday. Okay, so if these 2 are congruent, how can I set this up? Perfect, they're equal to each other. Okay? All right, what do I know about if I create a quadrilateral, what do I know about the opposite angles? They're supplementary. Awesome. So opposite angles are supplementary. Okay? So then how would I set that up if they equal 180? Person. Perfect. Okay. I was going to say perfect and awesome, and it came out person. All right. Plus 8x minus 31 equals 180. Okay. That's one of the things that we learned. So inscribed angles, when they make a quadrilateral, the opposite angles are supplementary. Okay, which of the following diagrams is QR tangent to circle S? So that just means it has to be a Pythagorean triple. All right. So if this is the radius, what section is this? 8. So then what's the length of the hypotenuse? 15. All right. So 8 squared plus 12 squared. We have to see if it equals 15 squared. Okay?
Why
Sure.
would it be 8?
Because we have to do the whole hypotenuse for the thing. For
How did you know that?
because this is the radius, and the radius is the same no matter where I draw it. Okay, so 64 plus 144. So 208. All right, does 208 equal 225?
No.
Thank you. Talk to me, please. All right, so is this a right triangle? No. So then can this line be tangent?
No.
No. Thanks, Drew. All right, so let's look at the next one. All right. this is the radius 7.2, so what do I know about the other side? 7.2. Alright, so the whole length is 14.4. So there's my right angle because it's a tangent line to a radius. So we'll do 10.8 squared plus 14.4 squared. Does it equal 18 squared? Alright, when you do this in your calculator, you'll get 324 equals 324. Is that true? Yes. So is this a right triangle? So then is this line tangent to my circle? Yes. Alright, so that's a little hodgepodge of things that we've learned throughout this module. Okay?
When we did the same thing for C, just 14 squared, 19 squared equals 1 squared.
Yes. And it doesn't work. Just to let you know. Alright, so today is a paper day. So I gave you the notes. I normally do this one as a discovery activity, but since we are kind of pressed for time on this module, I decided not to. And it's like a lot of folding, and we know how much Gabe loves folding things, right? Like a lot of folding and measuring and folding again and folding again and measuring again. So, and it takes a really long time. It's fun, I like it, but it takes a long time. Okay. Do I have anything? Oh, I just put the answer key up there. Okay. So here you go. So while I'm looking for my non-filled out one, you can get started on that. Oh no, I didn't record that. Oh, I am recording. Okay. Alright, y'all give me a couple seconds. Sorry. Hold on.